Hello, dear online learners. Welcome to the Lesson BC YouTube channel. 1 year ago, we launched our mechanics physics course. In the upcoming months, we will launch the second part of our physics lessons, electricity and magnetism. In today's lesson, 2 online teachers will present solved problems and detailed explanations on Coulomb's law and electric potential energy. Stay tuned, and let's begin our journey.
Okay, so how do we actually calculate that invisible push and pull between electric charges? Let's dive in. We all know the basics, right? Likes repel, opposites attract. But how strong is that force really? See, going from just watching it happen to actually measuring it, well, that's everything. Time for some math. And the tool we need for that is Coulomb's law. It's a huge deal in electrostatics. This simple-looking formula is super powerful. It tells us exactly how 2 charges are going to interact. So what does all this stuff mean? Let's break down the symbols real quick. All right, the best way to get this is to actually use it. So let's do the math together. We're going to follow a really simple 4-step process to get our answer. First up, the problem. We've got 2 particles, we know their charges, and we know how far apart they are. Okay, step 2, identify the variables. Heads up, we have to convert everything to standard units first. Now that everything's in the right units, we just plug those numbers straight into the formula. And boom! After running the numbers, we get a force of 350 newtons. Okay, 350 newtons. But so what? What does that force actually do to these particles? To figure that out, we gotta bring in another physics legend, Sir Isaac Newton. You probably remember this one. Force equals mass times acceleration. A force makes things move. And here's where it gets cool. One law calculates the force, the other tells us what happens because of it. So let's use our 350 newtons to see how fast particle 1 is going to accelerate. It's easy. We just flip Newton's formula around and plug in the force and the mass. Whoa, that acceleration is absolutely insane. That's what you get with a huge force on a tiny mass. And since both charges are positive, that insane acceleration is pushing them directly apart. So let's wrap this up. What did we just learn here? Think about it. If one law can explain this, what bigger secrets of the universe can it help us solve?
Start by breaking down Coulomb's law, which describes the force between 2 charged objects. The law states that the magnitude of the electrostatic force between 2-point charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. The formula is F equals K Q2/R2, where F is the force, K is Coulomb's constant, Q1 and Q2 are the charges, and R is the distance. This law is fundamental in physics and helps us understand how charged particles interact. Now let's see how to apply this law with a practical example, making the concept clearer and more relatable. Imagine 2-point charges. Q1 equals 2 mu c and Q2 equals 3 mu c placed 0.5 meters apart. To find the force between them, we use Coulomb's law, plugging in the values. F equals 8.99 times 10·9 nm2/c2 times 2 times 10·6c times 3 times 10·6c, 0.5 m2. This gives us F equals 8.99 times 10·9 times 6 times 10/0.25, which simplifies to F approximately, and this force is repulsive since both charges are positive. This example shows how straightforward calculations can be when you follow the formula step by step. Next, we'll see how electric potential energy is related to these charges. Now let's calculate the electric potential energy between the same 2 charges. The formula is U equals K Q1 Q2/R, substituting the values. U equals 8.99 times 10·9 nm2/c2 times 2 times 10·6c times 3 times 10·6c slash 0.5 m. This results in U equals 8.99 times 10·9 times 6 times 10/0.5, which simplifies to U approximately 0.108 J. This value represents the work needed to bring the charges from infinity to their current separation. Understanding these calculations helps us see the connection between force and energy in electrostatics. With these practical examples, you can confidently solve similar problems in your studies.
That is all about today's lesson. If you have any questions, write on the comments section and the online teacher will reply to you. Do not forget like and subscribe our Physics and ICT YouTube channel. Thank you online teacher, thank you online students. See you in another lesson. Until then, goodbye everyone.